Hello everyone, I welcome back you all again to the another video. I am Deepika, currently pursuing my 4th sem in Sri Venkateswara College of Engineering from the Department of Computer Science Engineering. Today in this video, I will be discussing about the subject called Analysis and the Design of Algorithm, and particularly about the topic called Prim's algorithm. Now let me discuss about the Prim's algorithm. Prim's algorithm is a classic algorithm used for finding the minimum spanning tree of weighted undirected graph. A minimum spanning tree connects all the vertices in the graph with the minimum total edge weight with no cycles. This algorithm is efficiently and widely used in the network design and which are related to the applications. The minimum spanning tree connects all the vertices in the graph with the minimum total edge weight. This minimum spanning tree has no cycles and includes all the vertices of the graph. Finding the minimum spanning tree is crucial in various applications, including circuit design and the network routing. The main characteristics of the Prim's algorithm is the Prim's algorithm works by building the minimum spanning tree incrementally. It starts with a single vertex and adds one edge at a time, extending the tree. This algorithm always selects the smallest edge that connects the vertex in the tree to the vertex outside the tree. Now let us see about the algorithm step. First we have to initialize an empty set of the minimum spanning tree at the priority queue of the edge and add a arbitrary starting vertex to the minimum spanning tree and its edge. Repeat until all the vertices are included in the minimum spanning tree. Always choose the smallest edge from the priority. The input for the Prim's algorithm is weighted undirected graph represented in the various form like adjacent list or a matrix. The output in the minimum spanning tree which can be represented as an set of edge or a new graph. This output ensures that all the vertices are connected with at least total edge weight. The time complexity of the Prim's algorithm depends upon the data structure used for the implementation. Using the priority queue implemented with the binary heap results in a time complexity. For the dense graph, an adjacent matrix can leads to the big O V square complexity, which may be a less efficient. The Prim's algorithm is oftenly compared to the Kruskal's algorithm method for finding the minimum spanning tree. While Prim's is more efficient for the dense graph, Crucial maybe performs better on the sparse graph. The choice between this algorithm depends upon the graph's characteristics and the specific. Now let us take a small example. We begin the Prim's algorithm from the vertex A and initially the tree contains all the vertices. From A, we look all the connecting edges and we find the smallest weighting edge, that is A to C with the weight 2. So we add the vertex C to the tree. Now from A and C, we consider all the edges connecting to the non-tree vertices and the smallest is C to B with the weight 3. So we add the vertex B with A, C, B in the tree. The smallest new edge is C to E with the vertex 4. So we add the vertex E. Next from the tree A, C, B, E, the smallest edges is E to F with the weight 3. So we add the vertex 4. Now with A, C, B, E, F, the smallest edge connecting a new vertex is C to D with the weight 4. So we add the vertex 4 and all the vertices are now included in the tree and we have to build this minimum spanning tree and the minimum spanning tree is 16. The visual representation of the Prim's algorithm can greatly enhance the understanding. Diagram can illustrate each step showing how the minimum spanning tree grows incrementally. Graphical representation can also highlight the selected edges and the current state of minimum spanning. The Prim's algorithm can be implemented in a various programming language including Python and Java, and the developers oftenly utilize the priority queues and the adjacent list to optimize the performance. Proper implementation ensures the correctness and the efficiency and critical for the larger graph. The main limitation of the Prim's algorithm is not suitable for the directed graph or a graph with the negative edge weight. The algorithm may also become inefficient if not implemented with an appropriate data structure. And additionally, it requires all the vertices to be connected, which may or not be the case in the sum graph. Prim's algorithm is a powerful tool for finding the minimum spanning tree in a graph. It incrementally approach and efficiency make it suitable for various applications. Understanding this algorithm is essential for solving the network optimization and the problem efficiency. And this Prim's algorithm is a simple, efficient, and well suited for the dense graph when using an adjacent matrix or a sparse graph with a mini priority queue.